Hello students, welcome to Inside Physics. Today we will discuss how to determine the crystal structure using Lois method. See, in crystallography, we know that all the crystals are divided into so many systems which are single crystal, polycrystalline and amorphous crystals. But the curiosity is all about the crystal structures, how to get the crystal structure, and there are various methods, and one of the good method in this crystallography is Lois method. This method uses the Bragg's principle. So what does the Bragg principle says means, if the X-rays, they are very powerful electromagnetic radiation which are created by the very high energetic electrons when they are bombarded with a metallic anode. So the number of electrons hitting the metallic anode produces the X-rays. So the X-rays are powerful electromagnetic radiation which can enter into the atomic planes inside, and they can create a diffraction pattern. So the diffraction pattern is recorded on a photographic film. So the crystal structure is understood based on the diffraction pattern. So we see how it goes. Lois method, there is an X-ray tube in which the X-rays are produced. So there is a target which is a metal, and the high energetic electrons are hit by the this metal is hit by the high energy electrons, and the X-rays will pass through two lead slits S1 and S2. So the lead slit will be making the beam, X-ray beam, as a collimated beam, and the other beams which are falling on the lead slits are absorbed. So the collimated beam is very narrow and it hits the crystal which is mounted in the path of this X-ray beam. So this is almost a thick and large crystal of considerable size. So in this we already know, according to crystal structure what we have studied in the previous classes, the atomic planes which are called, when it is observed with Bragg's law, they are called Bragg planes. The lattice planes are the one which deviates the powerful X-rays in all directions. So they all move in all directions and they create a particular pattern of diffraction pattern. So if you observe, each atomic plane will deviate a particular X-ray beam in a particular angle. So the diffraction pattern observed is almost considerably depicts the crystal structure. So it almost gives the outline of the crystal structure. So what happens inside this crystal? So each atomic plane is having some lattice points. Lattice points are which they are having some atoms at that point. Each lattice point is having an atom, and each atom diffracts a X-ray beam almost to different angles. So in this way, all the atomic planes are the ones which diffract the X-ray beam. So what happens when the X-rays are diffracted in all directions? So these diffractions will create a bright spots, high intensity spots. So those are called Lois spots. So this is Lois method and they are called Lois spots, and those spots are representing the atomic planes. Each spot, we can see the undiffracted beam here is represented with a central bright spot. Naturally, when we are recording on the photographic film the diffraction pattern, we remove this part because the central undeviated X-ray beam is not recorded. So it is not necessary for us, because the diffracted beams are necessary for us, and the angular positions and the angles they make with each other, the angular positions of these bright spots are required for us to understand the orientation of atomic planes and crystal structure. So here there are two types of Lois method which are back reflection method and transmission method. Okay, these these Lois spots or bright spots are giving the structure of atomic planes. So in this way we can consider this photographic film if backside the crystal, that is called back reflection method, transmission method. So if we consider the photographic film and put behind the crystal, it is called transmission Lois method. If this photographic film is put in between the X-ray tube and the crystal, then this is called back reflection method. See, if we put the recording plate or photographic plate here, that means all the diffracted rays backwards will be recorded on the plate here. So that provides a different diffraction pattern, and also we can get an estimation of the orientation of atomic planes and crystal structure in the back reflection method also. But here in this diagram, see, I have given the transmission Lois method. So here that bright spots are understood based on two types of charts. One chart is Greninger chart, and the second one is Leonhard chart. So what is these charts means? There is a particular pattern in Greninger chart and Leonhard chart where we can compare these charts with the pattern of this bright spot, and we can understand the orientation of atomic planes and crystal structure. So these Lois spots are used by two scientists, Friedrich and Lehmann. So these two scientists used the Lois spots, and they actually measured the wavelength of X-rays by considering the angular positions of Lois spots and the interatomic distance, that means interplanar distance. So the two types are basically to understand the crystal structure, and this is the very good method, but it also has some advantages and disadvantages. These are the charts, and we now study what are the advantages and disadvantages of this method. First one, advantages we see. So by this method we can understand the crystal orientations and the atomic plane structure of the given crystal with the help of a simple setup like this X-ray diffraction method. Okay, and other advantage in this Lois method is it is useful for analyzing specimens that are thick and large. Okay, see, when it is, when the crystal is thick and large, this can be understood by this method. So the limitations, now we see what are the disadvantages or limitations of Lois method. So basically we do not know the wavelength of X-rays which are being diffracted by the atomic planes and creating the spots. See, each spot here represents an atomic plane. So this spot and this spot, so all the pattern, that is, this is a pattern, it is, looks like it is having some specific pattern, it is very specific to a particular crystal. So if you use different crystal here, it provides a different pattern. So in that way, if you can understand different crystal properties, if you take some crystal properties and match it with the diffraction pattern, you may have some similarities regarding their properties, their characteristics like melting point, their density, and their resistivity. These are the properties that we can understand by understanding the specific pattern. But here are the limitations of this method, and we don't know the wavelength of the specific X-ray beam which is being diffracted by a lattice point. So we cannot understand the orientation of the lattice planes in detail. So that is the limitation. And next one, it is only used for single crystals, not polycrystalline. So if a single crystal is used, it gives a definite pattern, and if it is a polycrystalline crystal is used, it gives a complex pattern. So complex pattern may not be understood that much easily, so we cannot understand the structure of the crystal. And the third limitation here is it is useful only for large crystals. So if the specimen, if you are given a small specimen, so you may not be able to get a good result because in this method. So it requires a minimum size of the crystal, so we can have the diffraction pattern. These are the limitations. So overcoming the limitations and understanding the diffraction pattern, we may end up with understanding the crystal orientation and the structure in somewhat a better way. Okay, this is how the Lois method works, and in the next session we will come across another method to understand the crystal structure. Thank you.